Okay, first of all, what we did, let me explain what we have done so far. It's a simple application that we have created in order to demonstrate the power of MVVM. First, we created the model and the view. Sorry, first we create view and view model in the first lecture. Then on the second lecture, we introduce model to this section. So by doing that, what we have done, we have introduced a lot of has been terminated. Okay, let me think my APIs are outdated. Let me delete these things. Probably I did update on my machine. That's might be the issue. I'll create a pixel, pixel Excel. Next, think I have 33 API level. Next, pixel Excel 33. Enable. I don't need the device form. Show advanced setting. I would always go for call boot. Finishing. So by doing the MVVM introduction, first we created the view and the view model. Then we interacted with those things using observables. And second thing that we did is that we worked with something like the model itself, and we were able to get that in place as well. Give me a second, guys. I think I'm having a trouble with my emulator. Not sure it is why it is not working. We have created these devices. Device manager, view mode, resize. The emulator process for AVD Pixel has been terminated. What does that mean? That's what happens when you do a new version update. By the way, I updated to the latest version of Android Studios. That might be the case. Flamingo. Probably you guys should go ahead with that. By doing that, I think I have broken my virtual device and everything. Studios and plugin installed. Okay. Okay, device explorer. Device manager. I should see the. Okay, there is the. Let me delete these things so I can create a brand new one out of everything. Not gonna need this. Okay. I'll create a new device. It's gonna be a phone. Let's go with something small. I don't want huge one. So I have API level 33 based Android. Okay, we'll go with portrait. Enable device frame. I don't need that. I would have a decent amount of RAM. I don't need the device frame. I would like the call boot. Always go with the call boot most of the time. It does not work. Okay, back to. I think I'm good. Let's see, it's booting up. So yeah, as we were talking, we initially had a simple way of getting data, and then we introduced the model. The model was uh, quite a little bit tricky to introduce. So we had to introduce some of the neat and sweet stuff when we are dealing with an Android application. Those are what we call a dependency injection. Okay, so the popular choice among the Android community, what we called is Hilt. Hilt is a dependency management tool based on Dagger 2 actually. So Dagger 2 is also a dependency injection tool that's have new features, and we have something like Hilt. So Hilt introduction, we have done quite a lot of configuration in a nutshell. What we have done is in our application, we introduce module based in our app module, which represent the application level configurations. We have introduced a few things. Of course, the lifecycle view model was there already. We have introduced retrofit and a JSON converter, which help us to get the details. In this case, we were using a REST API to get these details from GitHub. So this helped us a lot with getting those details from that server. Okay, it was the easiest thing that retrofit implementation was the easiest thing. We already did this in a previous lecture series. So if you have any doubts on retrofit, let's please check those things out. And the other things that we have introduced is the Hilt, and Hilt as a dependency management tool. And these things is only for dependency section that we need right now. And one important thing that we have done is this data binding enable, which help us in a way where we don't need to bind variables using find view by ID and all those things. It's the variables can be accessed from the XML itself. I'll give you a quick tour on this, but remember, when you are enabling view binding, you have to be in a certain level of Android Studio, as well as the SDK versions should be updated. But we'll be leveraging the Android data binding to make things easier when we are dealing with view and the corresponding data binding in the Kotlin code. Okay, so this is one neat trick. Probably you will find these things in an existing project, but if you are coming to a new project which will be using something like Jetpack Compose, you won't find these things for sure. So make sure you have these things installed within your installed or enabled by default in your application, so you can leverage new things. So we will go one more time with the walkthrough. If you guys can remember, we have something when we are introducing these data binding. Okay, when we introduce data binding, Android will automatically generate data bindings for us. Okay, these things are automatically generated. We don't have to worry about it, but we will be using these things throughout the application. So as soon as you do this, once the project is configured, there will be some automatically generated files that we can leverage on. So we will go first with the application itself. So one thing we did, we introduced something called the application. Okay, because when we are dealing with a normal Android application, you won't probably find this application definition as a normal application developer. It will be automatically taken by the existing application from the Android ecosystem. But since we are introducing Hilt dependency injection, we need to inject HILT into our application. So we annotate our application with @HILT Android app. Then one important thing that we need to do as soon as we implemented the new my application main application class, which we override with HILT Android application, but the Android or the Android does not know about new introduction. It will be, unless we are told, it will be using the old configuration or old application. So in order to change that, we went to the main manifest and we have introduced in the application section, we have introduced the main application as the starting point for our application. Okay, so that is something we did. Also, one thing that we forgot to do is introducing the internet permissions. So I have done that one as well. So by introducing the internet users internet permission, we will be able to communicate with the outside GitHub repository. So done with the application, then we inject the application in there. Then what we have done is the activity. Of course, this is something like we normally know, but the only additional thing that we have done is that we have introduced Android entry point. Okay, this is something that HILT also need to do. We have introduced this Android entry point. In that way, okay, the HILT is saying, okay, now when we are dealing with dependency injection, this is a place to be considered as well. Okay, so this is also done. Yeah, it's like unwanted important. Let me remove that. So now HILT is aware of the activity as well. So within this activity, this app compact activity or main activity that we are having, we can inject dependencies using HILT. Okay, but right now in this main activity, we do not have anything to inject. So we are good with that. And the other thing is we need to talk about is dependency injection. Okay, in order to inject things, in order to inject dependencies to somewhere else, what we need is a declaration of these things. The main application automatically invokes main activity, right? Automatically, no, we have to define that. So the question I got right now is a main application automatically invokes the main activity. Okay, so what we have, since we have customized the main application, the question is, are we invoking the main activity automatically? No, that is not automatic, but we have defined in the manifest. Okay, you guys can see that in the main application we have the activity definition. Then within the activity definition, we have the main activity defined in here. As you guys can remember, application can have multiple activities, but one activity will be the first responder for the main launcher. So that is done by this intent filter. So we can have multiple activities. Within this multiple activity, this one will be the activity that will be launched, or this activity will be shown to you when you launch your application from the launcher or some app launcher. So this indicates this will be this main the activity that we are in will be the front-facing view, and it is defined by this main activity. So now, in a way, the application should have this definition. Without this definition, there is no like automatically detecting these things. That is not the case. We have to define. Since it is already defined there, it is detecting. Okay, not there is no automatically detecting these things. If for some reason, say we had another activity, but if we haven't defined it in the application, you won't get you won't be able to invoke that or call that unless you have defined it in the Android manifest under the application. Okay, So most of the time, current application architectures, you will find a single activity but with multiple fragments, because considering the cost of managing an activity, fragments are smaller in size and less in memory footprint as well. So we will have one single activity within the application, but in a rare case, if you want multiple multiple activities, yes, you can have it here, but you have to define it in here. Otherwise, there is no automatic way. Does that answer your question, Dinuka, right? Yeah.
Yes, sir.
Okay. So we have the main activity, and main activity is considered as the entry point for application, at least for the HILT. Now, as I mentioned earlier, since we need these application to, we need these applications to be dependency injectable. That means we have dependencies. Okay. Example, in our model, okay, we will be depending on retrofit. Okay, in order to make a REST request, a REST call for the outside world, we need retrofit. Okay, so model is depending on retrofit or some derived thing from retrofit. So retrofit should be injected to somewhere else. But retrofit can be initiated each and every time if you like creating a new instance and all those things. There are few drawbacks if you are not using dependent injection. The first thing that you will lead these memory issues. Okay, and you need to clean up everything after you are done with that. So all those things can be mitigated. I'm not saying eliminated, can be mitigated if you are working with something like a dependency injection tool. Okay, so we have to define the app definitions, and remember we call this we have this DI section, DI package, and in here we have something called app module. Don't get confused with the Gradle modules. This is the module, the name module comes from what we call the HILT definitions. Okay, this is something coming from HILT app module from Dagger. As I mentioned earlier, Dagger is the underlying for HILT. So these are like things coming from HILT or Dagger. Okay, so so this is like the dependency definitions. Okay, this is not where the dependency injection happen, but in order to inject it somewhere, we have to define it somewhere. Okay, you need to inject a service or class or whatever into another place. But in order to do that, you need to define those things. You need to define those things in a place. So what we have done in here, we have defined few things. First thing is we have defined retrofit. So anyone in the application, if they need a retrofit instance, they can inject a retrofit. They can inject retrofit to their service without an issue. All we have to do is we have to say, okay, in order to get a retrofit instance, you will have to build it or you have to instantiate somehow. So I have instantiated using something like this, and we have given the JSON converter factory and everything. Now we have instantiated retrofit and we have an instance of it, and anyone who needs retrofit can inject anywhere in our application. Okay, right now a retrofit is needed for the GitHub service. Okay, this GitHub service is depending on retrofit. So we will be defining a GitHub service, but in order to define a GitHub service, we need retrofit to be instantiated first. Now, if you guys can see here, the construct in this function, we are passing retrofit instance. Since we already have provided retrofit in here, in this function, we have defined a way to give a retrofit instance. Now, when we are referring retrofit in here as a parameter, it knows okay, this retrofit is the retrofit they are asking is this instance that we have created earlier. So when we are instantiating provide the GitHub service, they are referring to this GitHub, this retrofit. Using that retrofit, I will create a GitHub service. So GitHub service is normal service that we have seen so far. It is not something big. So if we have some basic models that we would like to see. In here we have something called login. So this login is not a variable that we define, but the API itself is going to provide us this. Okay, there will be a variable called avatar_URL. That is also something provided by the API itself. And there are a lot of things that the API provides. Okay, we are just interested in these two in order to show. Okay, so GitHub service will do a GET request to users. By the way, in here we have defined the base URL. That means the URL itself is this base path and appended by users. Okay, so this will get all the users within that response. Okay, and it will be a list of GitHub users. Okay, that's the simplest GitHub service that you will see. So we have defined the two dependencies that we will be using in our application, and we can now inject retrofit or GitHub service. In here we have retrofit service, we have GitHub service. Anywhere within Dagger is approachable or Dagger is available, you can ask for these two instances within your application. So in our UI, we created one fragment, and make sure when you are doing a fragment instantiation, you have to have the Android at entry point in here. Otherwise, what will happen is this view model won't be able to recognize the view model injection. So we have said in here, the fragment is now known for HILT or Dagger dependency injection. Although even though we do not do this, we do not use any dependency injection in the fragment side. It will break the view model injection that we had earlier on. Okay, so looking at the fragment itself, it's quite simple. We created the fragment, and we have something called bindings in here. Okay, the bindings that's something coming from the data binding that we enable in the Gradle file. Okay, when you enable data bindings, it makes us it makes our life a little bit easier to finding these XML resources and all those things. Okay, probably you won't be using these things much in the future as we are moving toward Jetpack Composer related ones. But for now, it's good to know data binding is also there, and you won't get surprised if you come across something like this. So we have this binding. The binding is done by these data binding utils. We have to find the inflator, and the inflator is provided to us by the onCreate view and the layout that we are interested in, the container, and whether it is attaching to the parent or not. Okay, so we have initiated the binding. We already talked about lots of time about these view model instantiation. So I'm not going to go through once again. Simply, we are using the view model provider to get us instance of the view model for this fragment. Okay, and the next thing is that in our application, if you guys can see, the file explorer, device manage, replay. So if you guys can remember, within our application, we have a simple recycle view, which contains all the names of the GitHub users. Okay, that's the simplest thing. So we will be using the recycle view. Okay, and we have created an adapter for that. Let's go a little bit deeper in that in a little bit later. And the adapter we need to update as soon as we get some data from the view model users. If you guys can remember, always you guys should always get the information or data reactively. That means everything should be as an observer. So we have within the view model, we have something called users, and we are observing that. And once we get a list of users, we have the user list view adapter, which is binded to the recycle view. In here, we have something called set sims. Let me rename that something more useful. How can I refactor these things? Right click, refactor, rename. I will say adapter users. Okay, we don't in Kotlin word we don't use set assemblies. So adapters in there have the function called user. Whatever the values the user observable is offering, we are sending those things to the adapter. Then the adapter will re-render the recycle view. Okay, so this is something we need for the bindings view model. The bindings we will be using within our XML. So this is definition of that. I'll go once again for the definition on that as well. But first we will go to the view model. Okay, view model is pretty simple in this scenario. Now you guys can see that this is a
excuse me, sir.
Yeah, go ahead.
Sir, can you explain a bit about adapter pattern?
Yes, I will as soon as I'm done with the view model. Okay.
Okay, sir.
Okay, right. So first I will go with the view model users. Okay, those are view model users. It's really simple. We have something called mutable live data. If you guys can remember, we when we want to observe something, it should be immutable live data. Immutable live data. So we will have a list of GitHub users. Okay, that is the definition or the shape of our mutable live data. It's going to be a list of GitHub users. So how do I get this list of GitHub users? In the initial or within the constructor section, we have the injection of GitHub user service, and there is the method called users. If you guys can remember the definition that we have done in here, right here. So while when we do a call for that, we get a response. Within that response, we will have a body which contains the data, as you guys can remember. Within a REST request, you can have multiple things, the body, header, and there are like a lot of other metadata involved with the REST request. Right now, we are interested in only body. Okay, since we are only interested in body, we will get a response response.body, and we will assign that underscore user value to this response. And you guys can see that one thing that we have done in here, we do not directly expose this underscore user to the outside world. We use a private variable, and we have a variable called users, which is exactly same to this, and we can access users from there. This is like a common pattern in order to not to expose too much for the outside world, outside of the view model. So we have defined something like this, and by using this pattern, what we are doing is we are making this users underscore user not readable. Okay, so we are instantiating read-only variable call uses. Okay, it's pretty simple. And one thing to remember in here, that this GitHub service get users, this is a network call that should happen. So if you are trying to run this on the main thread, it will definitely get some errors within our application. You can't do any long running or main thread hogging application, main thread hogging any request or any computation on there. So we will be running this in a coroutine scope, okay, especially the view model scope, and we will launch a coroutine. This will be something like we are running on this background, and once it is done, please update the user values. Okay, this is like a mini thread, if you like. So this coroutine do these things outside of the main UI thread, and once it is done, it will update the users. Okay, so very simple view model. The main points that you guys need to be considered about, or you guys need to be worried about, is this at heel view model. So if you guys can remember, there are several points Hilt view model works. Okay, this is one of the points, like Android endpoints. And if you guys can, in the main activity here, we had Android entry point. Also within the fragment, we had the endpoint. And there are view model entry point as well. So the view model is aware of Hilt. Okay. So in order to do an injection, okay, we do a constructor level injection. So we'll be injecting the GitHub service, okay, and we will be using at inject annotation. And by doing this, we'll be providing a GitHub service from the dependency management system. In this case, Hill. You guys can see that GitHub service is something that we have defined in the app module. In this scenario, the Hilt app module. So we have defined GitHub service. So whenever somebody is using, in this case, the GitHub view model is asking for a injection of GitHub service. Of course, we have already defined it. No worries, I will give that definition in here. I will inject that in here. You don't have to create a new instance out of it and work with it. Already the instance is there. You just work with it. So we called the GitHub service.users method, got the response, assigned it to here. And each and every time when we are doing something, when we are calling this method, what happens is it calls the underlying API, and everything is initiated, and we will get a new set of users. Okay, the view model is really simple. We have introduced the model, and you guys can see one other thing in here. We have the view model, which is invoking the users, and we are getting the response in here, and we are getting the body of it. Okay, but there is a small violation here, as you guys can see. If you guys can clearly remember, when we are talking to the GitHub service, okay, if you remember, when we are talking to the GitHub service, we can invoke this. Okay, I can say GitHub service get all users, but the problem is we can't access the values like this. Okay, this is an anti-pattern. Okay, for demonstration purpose, yes, we have put it in here. We will decompose this to the next level as well. In that way, what we will do is we will be only sending GitHub get user service, and it should reactively in the model, in the view model, in the model, it should reactively send us the data in order to work. In this scenario, we are clearly violating this. We are calling that service, and we are getting the response in the same call. This is a violation. You guys can remember when you are dealing with the view model and the model, we can request something, but the response or whatever the value that we supposed to send should be reactively sent. Okay, this is a clear violation, but for now, we will stick with this anti-pattern and we will fix this in the future. Otherwise, it will the result, the taking result part will take much more longer. That's why I took the shortcut. But remember, this is something like an anti-pattern. Okay, so this view model is really simple. As you guys requested, I'll go with the what do you call the adapter pattern. Okay, how we gonna do a recycle view adapter implementation. So since we are using the bindings, okay, we are using the view bindings. We have something called root. Root in the sense, whatever the view binding that we are doing, the root of that view or the most higher order component or the top in the hierarchy is called the root. So if I look at the this is the binding that we are doing for this fragment GitHub. Okay, so in here, the most top or most hierarchical element is layout. Okay, so we are referring this when we are talking in terms of root. So binding.root means this layout or this XML definition. Okay, so we have this XML, and in here you will find a recycle view called id.user recycle view. Do we have something like that? Yes, we have a recycle view, user recycle view. So we are referring to this recycle view when we are talking about the recycle view. It's a simple recycle view. You guys can see, I'm not sure. It's just showing, it just have a reference to the recycle view. We do not have the definition for one single item. We will get back to that. Right now, we are just defining a simple binding for this recycle view. Recycle view is like that is like a adapter pattern for list or something like when we are not using the elements that we are seeing. If you are seeing only 10 elements, we do not render all the 100 elements since in a list or in a grid, whatever the UI that we are supposed to show in a recycle view, it can hold more than the visible area. In recycle view, they automatically only shows what our user is looking at. All the other things are not shown unless they are requested by the user to show. So recycle view, we have reference to that. This is the recycle view that we will be working with. Okay, and we have given okay in this recycle view a list item, one single list item would look like something this. It is defined by layout.github user view. Okay, so one single user sorry, one single user would look like something this. Okay, so it is also a layout view. We'll talk about these data bindings in a little bit later. So it's going to have a constraint layout. Within that constraint layout, you will find a text view. So if you look at this split view, and if I can zoom in here, I'm not sure whether you guys can clearly show all the things. So it is just like a normal list text view right now, and it's just simply showing a name, but we can make this list view um, more more interesting, or we can have this list view with more details, like we can have the emails or something like that. We can do that. Actually, why don't we do that? So you guys get an idea on how that also works. So right now, we are interested in user login, but for some reason, let's say we want the first of all, let me get what are the available ones in the GitHub user. This is the base URL. So let me give, where's my browser? So browser, where are you? Okay, I think I have API/users. In here, I have the login. I have something called node ID, type. Let's go with something simple. Let's have the URL. Okay, we'll be working with, or we will go with type. So it is repetitive, so it's not gonna something unique. Let's use the node ID. I'm not sure what it is, but it is something unique, so we can see the difference. Okay, so we have to update our definition. We have to go to GitHub service. Also, we have to add this variable node ID. It's going to be a type of string. Okay, since we only looked on login and avatar URL, now we have another one. Remember node ID. So if I go in here, I will have two text views. Okay, so the first one is the user login. Next one is node ID, as it says. So I can easily have this layout wrap. It will be something like this. End of parent, and I would go with the bottom constraint, so I can see it. Layout constraint, I would say bottom. Button to top of user login. Okay, so we have two different text views. One is for user login, to show the user login. The other one is to show the node ID. Okay, so this is how it's gonna look like a single row. Okay, a single row will have two text views. Okay, for simplicity, first one will show the user login. The second one will show, the first one will show the user login. The second one will just show user node ID. That's simple as it is. If you're having trouble with the constraint layout, also you can, you don't have to use the constraint layout. You can do something like a linear layout or something like that, if it makes it easy. But yeah, you can use anything you like in here. And I can have the bottom, constraint bottom to top of that. Okay. So we are not gonna go with working with the constraint layout at this moment. It's totally easy if you guys have learned in a different lecture. I think we covered thoroughly in the last lecture. Okay, so we have a recycle view, and we have one single view how it's gonna look like. All the other things are related to aligning it to somewhere else. Okay. And the other thing that we need to work in here is that let's say, for instance, in this scenario, this data binding is not actually relevant. Say, for instance, in the GitHub, in the fragment.github, we need to access to our view model. Okay, so we have the fragment.github.xml. Now we want to get some data from the view model we have in that fragment. So if you guys go here, this is the fragment Kotlin class. we have something called view model in here. Okay, we need to access this view model within our XML. We need to have the access to our view model within our XML. So we can do that by simply introducing data. And remember, in order to inject data, it should always be in the layout root. The root of this view should be in layout, and we can introduce data in here. So we are introducing a variable. Normally, the variable name should match with the the variable name that we are gonna bind. It is ideal to have those names as same as the fragment we are having. So in here we have view model, but in the XML, we can have a different name for that variable. Okay, that variable can be defined as VM or something like that. We can have something like that. But it is ideal to have it as the same as the name that you will find in our Kotlin class. Okay, so we are defining a variable called view model and the type. So this view model, how it's going to look like. So we know the typings and everything for this view model. We can simply define this type in here. So this view model, its type is going to be defined by this class. Okay, if it is something simple like a string, you can go ahead with string and all. If it is not something like something like a complex object, you can give the whole part for this. So the variable definition would look like what we have defined in this class. Okay, so this is how we can do data binding. We'll right now within this activity, I don't think we have use of this. I think it should work as it is, unless there is yeah, I think we need the view model for the later part. That's might be the case. Okay, we have just for now. You guys can remember. You guys can have to memorize this. We have a variable called view model, and it is something you will see in here. I think the UI is not looking good. Let me fix that. Otherwise, it's not that good to have. So we have this constraint layout. Let me use a linear layout, so it's easier. Linear layout. And what we need for the linear layout is few missing variables. Layout height. I would say layout height is web content. Layout width. Layout width is something we can say match parent. Okay, and I will put these two values in here. I'm not going to use the constraint layout. It's going to complicate things. So if I look at the UI right now, I think I have to give the linear layout direction or alignment. What is that? It's easy to go with the designer view, and I have this attribute section. Visibility is there, rotation, orientation. Okay, orientation I would go with horizontal. Okay, and that should do it. I don't think I need these layout related stuff which is needed by layout related stuff for that. And I would say width. Yeah, that would do. Let me check whether it is still visible. I just converted the constraint layout to a linear layout to make more things easy. Yeah, it's showing as expected. Right now, it is not looking good. We will add a divider or something like that later on. Okay, so this is one of the items that we will be working with. And in here, also we have defined two variables. Okay, this is coming from the data binding itself when we enable things. So we will have a variable called item and the shape of it, and it's going to be look like a GitHub user. You can say user if you like, since it is something like a GitHub user, whatever the variable name, but it's always what's suited for you. And we have instance for variable for the view model as well. So we have view model in, by the way, do not get confused this with Dagger dependency injection or something like that. This is completely what we call data binding. Okay, this is not like something Dagger would do. This is completely generated code by the data binding enable thing that we have done. Okay, so say for instance, we want within this text view, we have two different text views, and within one text view we need to bind the item, or I can simply say user, but I have to change it somewhere as GitHub user. I will say GitHub user, and I can say GitHub user, whatever the text for the first text view, I will have something like that, GitHub user login. And the second one is going to be GitHub user dot, what was that, node ID. Okay, so when we are binding for the next text view, we will be binding the node ID for the second text view. Do I have the list? It's not in the list layout, but I think it's in the recycler view. I have something called separate, right? To have the separate for the recycle view. Common attributes, background, alpha. Sure, they have separate. Getting confused. You say a divider or a separator, drawing. Don't think I have separate. Scroll bar X. No such a thing. What we can do is if I really want to separate, I can just have a line. To have a line that I can work with. Yeah, I think I can define it in the view. Right now, just let's go with the things we have. So we have the recycle view. We have the one single item for that. Okay, cool. And within in here, we will have two text views. Okay, within this text view, the first text view will bind the variable that we are giving to this. Okay, we will be giving a variable named GitHub user, and that GitHub users login will be binded to this text view. That is how we're gonna bind this text right here. And the second text view will have the GitHub users node ID variable. So it will be binded to this one. Okay, simple as that. So next thing that we want to do is we need to make sure this is the URL definition, XML definition. We need to make this happen, or we need to make this binding accessible in our adapter. Okay, let's go back to our adapter. We did not the view model. We talk about the service. Okay, so we get the recycle view. Okay, this is the recycle view. In order to recycle view to work, the recycle view something called an adapter. Okay, this think this adapter as the handler for the recycle view. The recycle view should know, okay, what are the items that we are getting, how many items that we're gonna show, and when we get a single item, how do we do the binding? All those things are directed, or all those things will be uh, handled by this adapter. Okay, so it is the adapter's responsibility to create our data for the view. Okay, so we'll be creating our own adapter called user list adapter. In order to create an adapter, you will need the context where this is running and who is the life cycle of this, and the view model we need to access. Okay, so we will go with the list view adapter first, and I think this is a little bit of a complicated code, but we'll try to explain as much as possible. So we have this list view adapter. As you guys can remember, we are getting a context, the lifecycle owner, and the view model in order to work within our application. Okay, all right. So we are creating a recycle view adapter based. We are creating a recycle view adapter based on this user list adapter user view holder. So this is an inner class within our application. You guys can see I have defined this inner class in here. So this inner class is gonna do the initial binding for a particular item that we will find. Okay, so this is the shape of the adapter. The shape will be something like this user inner holder. So we are looking at that. We'll go one by one and see how this inner class shape our application. Okay, so next thing that we will see a list of GitHub users. In this scenario, it is called since. I will rename that to something more useful, something like GitHub users. Okay, that would make more sense. We will have a list of GitHub users. Initially, it's going to be an empty list. And we will be using with the inflator in order to convert one single row from our XML view to our UI. Okay, so we will be using the layout inflator for that. That is why we need the context. Without the context, we can't access the other things. So we will be making, we will be utilizing the layout inflator in order to convert one single row to the data binding that we have. Okay, so in our user view holding, we will have the item view, which is simply a view, and we will have the bindings, we will have the view model, and we have the lifecycle owner, as well as somewhere. So we will be giving a recycle view holder based on this item view. Okay, so only function that you will need to do is the binding. Okay, so if you guys can remember, within the binding, I changed the variable name from data. If I go back to the fragment itself, I can show you guys. Layout, resources, layout, GitHub user view. Okay, so within the bindings or data bindings, I have defined two variables. One is called the GitHub user, the other one is called view model. Actually, I don't think the view model is needed at this point, but we'll see. So I have defined two variables, but I'm using the item in here, but the name should be GitHub user. Okay, I have defined the variable name GitHub user, so it should be like this. And I have defined a variable called view model. That's why it is in here. And we have to execute this binding, execute binding, and we have to say when you are doing the binding, who is the lifecycle owner. Okay, we need to do these bindings within our application. Make sure the variables that you have defined in here, two variables that we have defined. We need to bind those things, otherwise it will not work. Okay, we have to provide the binding if you are accessing them from our view. Let's see whether the application still runs. I think it did still run, but I can make it a little bit. I'm not sure. I'm not comfortable. Can I have padding in here? Padding bottom, let's say 4 dps. At least it might have some spacing in there. Yeah, still not that convincing. Let me change the size. I think font size, right? Or is it size? Text size. Let's say 12 dp, and I would have this one to have like 8 dp. So we can differentiate the list. Otherwise, it looks ugly. Okay, yes, we have the UI, but it is not that good. So I make this, let's say 16, and this one is 12. Rather than horizontal, let me make vertical. Let's see whether we have a good UI. Yeah, mostly readable. I would not give the award of the year for the UI, but yeah, so you have something something to be working. There you go. Isn't this look awesome? To me it is, but you guys decide. I have a padding in here. Padding left, I would say 8 dp. So we have two variables. One is called GitHub user, the other one is called view model. Right now we are not using the view model. So what I can do is I will just simply remove this. Okay, but obviously we will need that view model in the future. Right now, to demonstrate these things, I don't do, as you can see, if I remove that view model definition from there, I no longer need that, so I can remove that. So even in here, I can remove the view model if I like, and if I remove the view model from here, I can also remove it from here as well. Okay, so I can get the view model out of this equation, but if you like, we can keep it simple. But obviously, when we click on something, we need to execute something from the VM. So we might need it back. For now, I'll just remove it. Okay. So we have one. Let me see if that is working still. I think it is giving an error. Internal constructor. Okay, I think I have to remove it from the list adapter as well. So in here, no longer the view model is required. There you go. So if you have a definition, we have to bind it. If you do not have that definition, you can just skip it. Okay. So this inner class will do the binding for us. Since we have a variable, we will define that variable here. And the execution binding and lifecycle owner, those things should be binded as well. So the view holder in here, view holder have this class called bind. Okay, and it gives us an item. Let me refactor that as well. Refactor name, I will call GitHub user. Okay, so we have this binding method which we get a single GitHub user, and we use that variable to do the bindings in here. So this is like the view definition, view holder for our application. We can have it in our application like this. And on create view holder, you guys can see that when we are creating one single item, what is the binding that we're going to be using? Okay, GitHub user view binding. As you guys can see, it is the same username where we give the XML and capitalize with the ending name binding. So these are all auto-generated since we have enabled data binding. And using the data binding util, we have the inflator, we have the view, we know the parent and whether we want to attach. And when we are doing that, do the user view holder. In this scenario, this one, we have the inner class we have defined. Use this inner class in order to get the bindings done. Okay. So we have the user view holder where it should be binded. In here, you can see the item view and the bindings and the lifecycle owner. These are the three components that we are getting out of here. So we have this inner class, and this is where the binding happens. And binding view holder, this is the override function that the recycle view that we have to provide. Okay, the position and the view that we're gonna be binding. So when we are, since we are having a list of users, we can conditionally say, okay, these things should be binded or not. But in this scenario, we are binding all these things. So we have a variable called GitHub users. Initially, it is empty. You guys can see. And the position is the position where the recycle view is currently at. Okay. The position 0 should get from the GitHub users position 0 element, and we will bind it using the holder. So when we are talking about GitHub user position and we call the binding, what we are really doing is we are calling this bind method. Okay. So we have list of GitHub users and the current position of the list views that is visible. We take that particular user out of that user's position and we bind it with the user view holder. Okay, simple as that. And for recycle views, we need to provide the item counts in order to get the things done. In here, the item count is the item count that we have in the GitHub users, the array that we have defined in here. And the binding view holder, the current binding view holder, this is the same as what you will see in the on binding view holder. And the next thing is a set of users. How do we set these list of users? Well, we have defined a function called users, if you guys can remember. In the adapter binding, we have a variable called users. So adapter will have this users function. You guys can see we are setting that GitHub users to the values that we are getting in here. IT is for the GitHub users. And one important thing that we need to do, as soon as the data is changed, we have to say notify dataset has changed. Otherwise, what will happen is the adapter does not know, okay, the dataset has been updated. There are new users available. We need to re-render the UI. They does not know. So we need to call the notify data has changed as soon as we set a new set of users. Okay, this is to alert the adapter to say, hey, we got new users, now re-render. Do all those things all over again. Okay, that's kind of a statement that we are doing. So we have created the adapter. Any questions on this adapter that you guys need to know? Like really basics in here. I don't expect like huge things to be looked at it. It's really simple. If I'm using this in another application, I would definitely copy and paste, but I know what are the things I need to modify. That's it. Especially with the bindings, okay, the view holder. Probably these values will be the same. This function name should change because we are changing some things in the users. Otherwise, these things will be definitely same unless the a certain view, the certain view for a single row item would differ. That's it. All the other things are with the adapter is around 66 codes. Out of this, most probably you will copy paste all and you will just change a few of the username and the names and all this. Okay, any questions with this adapter? Okay, so we got the adapter ready. Next thing is, okay, we have an adapter. This is the adapter will do most of the bindings and all those things for a particular item. But the recycle view needs to know, do we need this? What is the view? The adapter that recycle view is going to be using. So we can call the recycle view adapter, and we can pass on this adapter variable for the recycle view. Okay, now recycle views knows, okay, I am a recycle view and I am going to adapt, or I am going to show data based on this user list adapter. Okay, and the layout manager for the layout, who is responsible for managing this layout, you can just always say linear layout manager. That is for the layout manager instance for the recycle view. And these bindings, okay, these bindings, if you guys can remember, the recycle user recycle view have a binding called data bindings or view model. If I don't need this, I can comment, but make sure the bindings in here is also needed. Otherwise, as you guys saw in the last section, it will complain, okay, the binding is not provided. Now you guys can see the view is looking good. Lifecycle owner we have set as we did on the fragment itself, and the binding route it is also provided to us. Okay, so really simple application, and we just got some data from the API itself, and we have displayed in here. Okay, so whenever we do a change to these users, okay, if we for instance we are changing the users, we have to come up with um, something more interesting. And let's say, for example, we have a button in here. When you click on the button, it will do another call, maybe get more data from the REST API and change it in here. But all those things should happen within the view model, and it should work. Okay. Any questions up until this explanation? So I think this is what we covered last time. I was giving explanation on that because we rushed at the ending last time. So now slowly, as we have seen everything, now we can slowly regain the knowledge what we have missed, what we have done. Okay, any doubts, anything that should be cleared, you guys can clear it from here. Any doubts? Anything to be clarified? Nothing. Okay. Awesome. So you guys can use this in Jetpack or Flutter the same as this way. Yeah, good question. Can we use this pattern in Jetpack Compose or Flutter in the same way? Well, are you referring to the pattern or I mean, a pattern in the sense the MVVM pattern or the adapter pattern? What do you want to know? Whether we want to adapt this in the Jetpack and Flutter? Yes, done. MVVM. Yes, MVVM. The pattern is it's gonna be the same pattern we're gonna be using. I think today's lecture is gonna be we will be doing this the MVVM way in Swift UI in Android. So we know there is little difference that we need to know, nothing really huge, nothing really big kind of thing. So we'll be looking at this MVVM implementation, both iOS and Android. So in Jetpack Compose, okay. So Jetpack Compose will have a different approach on doing that, but the concept behind it, the VM, the adapter will definitely change because these adapters are unique to XML binding. As you guys can see, the inflators and the create views, these are all something comes with XML binding. Okay, this adapter will definitely change, but what we can reuse with the MVVM pattern is the VM that we should be able to reuse. Okay, in this scenario, in this project, um, the view model that we have created, this view model we have created, and the model, the constructor, injectors, all those things can be reused in a Jetpack Compose application. The fragments, adapters, those are really binded to XML and XML related and views that the old way of doing these things. So probably these things won't be reusable with Jetpack Compose, but the view model and the services, all those things can be reused within Jetpack Compose. Okay, so even in Jetpack Compose, we can actually have this um, adapter level things in Jetpack Compose, but those are like really complex things unless you know what you are doing. I do not recommend those kind of approach, mixing these things. For example, the recycle view that we are having in the fragment can be in XML. The recycle view item that we see in here, the GitHub user view, that can be in Jetpack Compose. Okay, we can do such a mix, but I do not recommend. Let's go with something with a whole page or a whole section in Jetpack Compose. That would make more sense. But do not mix and match on everything. But the things that we can share, of course, the view model and the model, we can definitely share with Jetpack Compose. The pattern that this MVVM pattern, the same MVVM pattern, of course, you can definitely apply in any other frameworks if you know how to do the bindings and all. We'll see the same thing in Jetpack Compose as well as Swift. So you guys get the idea. Okay, this is the same thing that we did with basic Android using XML, and you will get the jinx of it. Okay, no need to worry about it. It's the same thing. Okay, we'll do this if the time permits. If you have more time, we will do this in the Flutter way. Okay, in Flutter we do not call this something like MVVM pattern. We call this as the block pattern. Okay, we will use the block pattern in Flutter, but underlying the concept is it is the same thing. Okay, the data flow is unidirectional and everything else the communication is unidirectional, and if you want to pass data you have to do it via an observer. Okay, same thing with Flutter, Swift UI, React Native, whatever you name it, the pattern is same. The way of implementing is going to be different. Okay, this is one way of doing that, and we will do the other way as well, so you guys can have a look around it. Okay, awesome, good questions. Any other questions that I need to answer before I move on? Yes, ask questions. That is the best way that you guys will get the knowledge, and that's the way that I am getting knowledge. Okay, otherwise I'm teaching you guys things I know by asking questions from me. I get to do a little bit of brainstorming if I don't know the answer, something that I do not get or did not have an idea on. I can do a brainstorm on that. That's fine. All good. Okay, Tarindu, you got the point with the MVVM and HILT. Abhishek? Rajit, you guys getting the concepts? Yes? Anybody did not get it? Please raise your hand. I did not get this. Okay, people who got the idea behind these things. I'm not saying all the things at once, but you know the idea behind it. Okay, I can at least try this my own. Raise your hand, please. Okay, I get the idea. Okay, only one person. Okay, two, at least 5 people. So I did not waste a lot of time. Okay, 3 people get it. Okay. So any place that we need to focus on. Okay, I might need a little bit explanation on this section. You guys can put it in the chat. I can go one more time. If you have any questions before moving on, remember always ask questions. If you're not curious enough, you're not learning that much. Anything you want to ask before we proceed? Because it's gonna get little. We do not have these concepts right now. The MVVM concept as we spoke right now. If you do not get this, the future is gonna be a little bit harder. Okay. You need to get the basics of this, otherwise moving forward it will be really hard. Okay. All right. Assume these things are clear enough. So I would go with the coroutine. Why we use a coroutine scope? Why we can't run in the main thread? Yeah, good question. So we have used the we can why we are using this coroutine scope rather than running in the main thread. Okay, so if you guys have seen, for example, let's take this network example. Okay, so you guys are looking in your application, you guys can see something in your UI. Okay, it's rendering. When you are scrolling down, you get the list of users like we do in here. There's the emulator. I can't see this thing. Start the application. Okay, so you guys, as a normal user, you guys just simply scrolling these things, scrolling down. Now we have come to an end. So what the program is going to do? Okay, now we need more data. We need more data to load. So when we hit the bottom, it will request more data. Okay, the requested data is not within our application, is not within our application. So what we need to do, we need to call the retrofit, and retrofit should get the data from the server should send the data, and once the data is done, we can show it in here. But think a situation when we are listening. This is rendering. This is the application is live rendering. Whenever we are scrolling, whatever we are doing, the application renders itself. Okay. Now, think what will happen during the time the main thread. Okay, the main thread is responsible for rendering this UI. Okay, so if we do a network request or if you do a huge computational task on the main thread, the same thread which is responsible for rendering the UI, and we are going to do a task which is like getting a data or doing a huge calculation. The main thread is going to get blocked when we are doing such a task. Okay, the main thread is going to get blocked. So when the main thread is get blocked, what will happen is the UI is not able to do its work. That means the rendering, it will not happen. So when we are scrolling up and down, the main UI is no longer responsive. The main UI is diverting its resources to do the network request. And what will happen eventually is our application is going to be no longer responsive. So if you guys have seen in some occasions, the application is not responding, force quit or something like some kind of message will be displayed. So that's kind of things will come when we are in a situation like this. Okay, instead of rendering the UI, we are diverting that resource to do a network call. Okay, and the network call is responsible for giving you all these information. Now the UI is blocked because of okay, we said okay, we have stopped rendering the UI, but we will be doing a network call on the main thread. Okay, the UI get not responsive. Immediately the user will think, oh, okay, this application is not working because the UI is stuck. Okay, so UI is stuck. We find these things. Okay, this is not working. Something is not working. Something is break or something has happened. So that kind of impression will use the user experience in a bad way. Okay, the user will have a bad experience on these things. So what will happen is the application that we supposed to that's supposed to give us more responsive things is crashing. Okay, the main problem with this kind of thing is, okay, you might say, okay, but when we are getting the GitHub users, it did not take that much time. The user will not notice. That is an exceptional case. Okay, if you have a good internet connection, if you have a good application, the good phone, of course, definitely this GitHub service get user will get the response very quickly. The user will even not notice this. But think a scenario where the internet is very bad and the server is very unresponsive. The server is taking, let's say, 2 seconds to respond, and the internet connector is not running on 4G or 5G. It is running on 3G or Edge. Okay, the network request will take 3 seconds to reach the server. The server will take 2 seconds to process it, and it will take another 5 seconds to reach back to you. So all that time, that all through that 10-second time period, your application seems to be freezed. Okay, it's not responding. As soon as your application is not responding for a couple of seconds, Android will decide, okay, this application is no longer responding. The main thread is no longer doing its work. Shall I force close? Okay, so that's the reason we do not interrupt the main thread. The main thread is responsible for smoothly running the UI. While we are running the UI, while we are doing the UI changes, we do not want to block that by doing some heavy task or network-oriented task. So it will block the UI and the user experience will be really damaged. Okay, so that's why we do not do such computationally intensive, network intensive IO related task within the main thread. Main thread will get hooked, the UI will get stuck. that answer your questions? So we subscribe for coroutine. Coroutine will do that in the background. Once it is updated, okay, once the data is received, the computation is done, whatever the things we do, it will give back the data. The UI will be updated. Okay. Any questions on this? So this, believe me or not, this is very easy. Okay. You guys in a time period where this doing a network request is like 3 or 4 lines of code. Okay. When I was starting at Android, this is it's actually in Java. And when we are doing Android in Java, we don't have coroutines. Coroutine is something from Kotlin. In Java, you have to use threads, and there is something called what was that called? Not background task executor or something like that. There was a task manager or something like that. I can't remember the name exactly. So it takes a lot of time if you guys ask me a whole class to get this done. Okay, the running the things in background, it takes what you call the things, what some kind of task. I can't exactly remember the name. We had to create a task, we had to terminate that task, and so on going on. It is really cumbersome when it is coming. Let me check the Java, that Java Android, that task. What is those tasks are called? Network. Can't remember, task manager or something like that. That was the asynchronous task. Okay, now I got this. So there is something called asynchronous task. If you guys are interested in have a look at asynchronous task, you will be surprised. So how much things that we need to do in order to do a simple task in the background, something like that, doing a network call. Okay, so consider you guys yourself lucky in since you know these things will take time, but now it's really that simple. That you guys need to do is all you guys need to do is select the code in scope and execute it. That is way more simple. Okay, any questions? Any questions before we move on? No? Okay. So the next assignment on this section is a really simple one, because we have already created the list view. The next thing that we want to do is when I click on this, when I click on one of these list view items, it should go to another page and show the full details of that user. Okay, really simple. When you click on one of these names, okay, it should go to another fragment, and within that fragment, you guys should show there is the avatar URL. That means the person's profile picture, and on the bottom, you guys have the what do you call this, login name. And if yeah, that would do. That is simply get an idea. So we have the user profile and the avatar on the next line. Okay, once you click on this, you click on it, a new page will appear. It will show the user avatar and the username on the bottom. Any questions on that? Any question on that assignment? You have to go with the MVVM model. Okay, you can't have hacks. Okay, any questions? Betum? Any questions on the assignment? Ashin, any questions? Akshila? You guys, anyone have any questions? Raise your hand, please. You can go once again. Okay, I assume you guys got the requirement. Simple one. Once you click on a list view item in here, go to a next page, show the user profile and the profile picture and the login name that you see in here, right under that. Okay, simple thing. Make sure you follow the MVVM pattern. Okay, do not get shortcuts. All right. Next thing that we will do, we will since we practiced these sections in the MVVM pattern in Android using Jetpack. Now we will we using XML. We will see how we can get these things in other platforms or other other frameworks, especially with something like Swift UI, and the same thing we can do it in Jetpack Compose. Okay, so in order to do that, we'll be looking at a, a quite new framework called Kotlin multi-module. Anybody have heard about Kotlin multi-platform for mobile? KMM for short. Anyone have heard about Kotlin multi-platform for mobile? No? Nobody have heard KMM? Okay. Only one, suppose. Okay. So let me give a brief idea on what's KMM purpose and how it is like differentiate from hybrid framework. Okay. So we have all you guys know that we have two main rivals or two main ecosystem in terms of smartphones right now, Android and iOS. Okay, so when you are developing an application, right now what we are doing is we are developing the application using Kotlin and XML, but think the same application we need to develop in iOS. Okay, so we'll be using something like Swift and a UI framework library or something similar to Flutter or Jetpack Compose, something like Swift UI. Okay, the UI part that we are going to do, it's going to be native. Okay, the native things going to be in a native environment. But what about the logic that we're going to do? Okay, say for example, we have the logics for getting information from the data. Okay, like we did in retrofit using retrofit. We took the information from internet and we put we did some conversation and we displayed in our list. Okay, if you take a close look at the MVVM pattern, okay, the view that we see is going to be different. Yes, the view that we're going to be seeing in our application is going to be different. The Android has a different view, iOS has a different view, but think about the logical part. The logical part that we are having, the VM and the model. Okay, VM and the model, view model and the model. Those things are going to be purely logical. Okay, so we can take a take a boundary on that situation, and we can say, hey, we can create the view twice, but why do we need to create the view model and the model 2 times in 2 different languages? Okay, what if we do it in a one single um, programming language and share among these 2 major platforms? Okay, so what we can do is we can write the view model and the model in Kotlin. Okay, the main base language for KMM is obviously Kotlin. We write most of the things in Kotlin, but the view we are seeing here is going to be native iOS or native Android. Okay, so by utilizing that, the logical part that we are writing is going to be written in one single code base, which is in Kotlin, and the UI itself, it's going to be in their native operating system. But the problem is, if you look at it, yes, Android can run Kotlin. We have done Kotlin in MVVM, and we can use Kotlin in order to write the logics. But in Swift or in iOS, you only have Swift. The Swift compiler does not know anything about Kotlin. They do not have a direct thing that whenever we are writing Kotlin, it's going to be in Kotlin. We can't convert those things into something like Swift. So the idea behind the Kotlin multi-platform is that whatever the logic that we are writing is gonna get cross-compiled to underlying operating system. So for Android, it's gonna be in since it is the native, you don't have to do any cross compilation or need to do any changes most of the time. But for iOS, the things in Swift, the things written in Kotlin can be translated into Swift. But remember, Swift is a high-level language. That means it is not it is making the developer life easy. But whenever we are compiling something in Swift, if you guys can remember, those things are getting compiled down to Objective-C. Okay, when you are using Swift, the code we have written at the end get converted to Objective-C. Then the iOS operating system knows about Objective-C and it works on and goes on. Okay, so what if we can convert that Kotlin code, whatever the Kotlin code, the VM model, VM and M code compiled to Objective-C, so it is going to be the native. It's going to be the same as the native code. So the UI, it's going to be native, and even though the VM and the other things that we have written is in Kotlin language, it gets cross-compiled to Objective-C stuff. So ultimately, when we are building the applications, it's gonna be one real native application. Okay, even though we write the logic in Kotlin, there is cross-compiled into the underlying language in this scenario Objective-C, and the application works as a native application. So the plus side of this approach is you can do the MVVM. You can do the M and the VM as a shared thing, but the view in its native forms. Okay, so by doing that, we do not we will have two native applications which does not depending on any other frameworks. Okay, but if you take hybrid frameworks like Flutter, React Native, what they are doing is completely different. What they are doing is they are running their own engine or a bridge this kind of middleman to do the conversation from Dart engine to native iOS or something to Android. They have a man in the middle, like a bridge or um, something like a bridge or a renderer to do those things. So oftenly we can consider frameworks like Flutter, React Native tend to be slow, but if you are developing applications in their native forms, truly native forms, we can consider those applications to have the maximum capacity or the maximum advantage that we can get from a native application. Okay, so know the difference. If you want really two native applications, of course you can obviously you can use KMM, which will do a lot of code sharing between the application, especially VM and the M part. But if you're using a hybrid framework, obviously everything is going to be on top of an engine or a bridge, but the performance will have a little bit of impact on each other based on the computational task that you are doing. It is not going to be same as native. As much as we try, the bridge or the engine will take some of your resources in order to work that. But I'm not telling that it is like gonna be like hundreds of megabytes or something like that. But even though if you truly need the performance to the last drain, the best thing is to go native. Okay, and by introducing KMM, you can reduce a lot of shared logic between these two platforms. Okay, we will create an application and we will see the true forms of MVVM on each platforms and how we can utilize that. Of course, if you like, by after you creating the MVVM stuff, but hey, I don't like this KMM stuff doing my logics. I don't want this thing to be happening in KMM. You are perfectly fine. You can do it on your native libraries, native things. That is totally okay. That is totally doable. The KMM which will be just there sitting, doing nothing. At the end, there won't be any code related to KMM or anything in the final bit. So you are free. No need to worry about even though we create a KMM based mobile application, at the end product there won't be anything. If you think this is too overhead, you can obviously go with native solutions. If you find yourself okay, we can do this in a shared way, you can do that. Okay, so code sharing will help you to do the same thing, same logical components without redundantly doing in the iOS as well as in the um, iOS as well as in the Android. Okay, you can share most of the logical parts. Okay, let's create an application and see what we are going with. So the creation of a KMM application, it's really simple. Probably the best place that you guys can start is the Android Studio. Okay, and remember, and the Android, even though if you don't have Android Studio, you can use command line tools. But I would highly recommend to go with KMM basic setup with Android. And remember, mm, uh, other logics still exist. Like if you want to build the application, since the applications can be really native. If you want to build an iOS application, you would need a Mac. Okay, those things going to be there. If you need to release this, you would need Xcode. Those limitations are going to be there. But in this approach, what we can do is we can reduce the number of logical components within a single application. Okay. Any Any doubts regarding the explanation with the hybrid and the native and the KMM approach? Anything that need to be clarified before we moving on? Okay, so the reason behind I'm showing these things, the power of MVVM first, because as you guys can see, by using leveraging technologies like KMM, we can completely remove the VM and M part to a different project, and we can work on solely on View. Okay, and we can completely share these codes. So that is like the most powerful thing that you will see within the application developments. Okay, and probably we'll be using the latest technologies like Swift UI and all those things. Let's see, I'll go to creating a new project, whether I have Kotlin multi-platform app. Okay, probably you will have this within the latest application, so don't worry about that. I would use the same project, the course code, otherwise I am getting so much SCNG. What's the course code again? 31. Okay, 31323 2023 KMM. It's going to be a lot of project otherwise. So it's going to be the same thing. And for Android, the package name is going to be this, where it's going to create the minimum SDK version, and so on and so forth. And the next one that you would see is something not in Android, but something related to Kotlin multi-platform. The Android application name. So as I mentioned earlier, this KMM module is going to generate two applications, one for iOS and one for Android. One for Android and one for iOS. You can name this application for simplicity. I would say stick with the default Android app and iOS app. These are the two applications KMM can generate, and I will have the default naming. And whenever we are having something shared, you can have a name different than that. If you have some restriction using shared O app by iOS app, Android app. If you have limitations, you can always change, but I will stick with the normal. Add sample test for shared module. That is something good. We will look in testing these things out. Framework in here. This is something for iOS framework. So if you guys know, iOS previously had something called CocoaPods, which is something similar to dependency management tool in Android like Gradle. So CocoaPod is responsible for getting the project's dependencies in order. But nowadays we use something called Swift Package Manager, SPM. So it's the regular framework that we're going to be using. I would not recommend for a new project to have CocoaPod as the package manager. Right now, I will just go with the regular framework, which is SPM. By Ruby, you need some, if you are using CocoaPods, they're giving a warning, you need Ruby. But I know we do not anything other than the regular framework. So CocoaPod is actually something not from Xcode or iOS development. It is completely driven by community and a third-party tool. So I would not introduce another tool into our distribution since we have something built in. Okay, and we do not need anything on this. I will just hit finish. It will take a little bit of time to create. This is the application that we have created. I'm going to close the old one. Yep. So it's going to take a little bit of time since I'm in the latest version of the latest version of the application. It's gonna download the Gradle and it is gonna take a little bit time. Let me do a package exploration. Still, so project. Okay. Till these things are getting loaded, till this it's gonna take a little bit time. While the application is creating, let's take a look at the project structure as of this point. Okay, it is something similar to what you will see, but it is not a purely Android application or an iOS application. So it's something um, totally different. But as you guys can see, Android app has the name that we have given. iOS app has the name that we have given. This is totally work. This iOS application, we can go ahead and install. We can go ahead and open this application in Xcode, and it will work perfectly without an issue. And this is the place where we will have all the shared code. That means anything related to sharing the logics, we will have these things in here. Okay, so you guys can see that there are a bunch of things that is happened in here. So we have Android main section, and we have something for unit tests for that section, and we have common main section for global use platforms. We have something for iOS as well. Okay, we will get through all these things right now. If you look at the project structure, it is the way that we have defined the application. Other than that, you have Gradle wrapper in here, which we'll be using to do our build stuff. And we will have, if you go to the Android app, you guys can see the build Gradle file. Okay, this is something similar. It is the equivalent of what we see in the application Gradle file. This is the same thing. And we have the source where we have all the Java or Kotlin related codes in here. Okay. For iOS, it's the same thing. We'll look into these things in a little bit later. I personally like to explain an iOS application from Xcode itself. But obviously you can use the other IDs like other IDs like Android Studio as well, but it's not going to be very helpful in terms of navigating and showing some of the files in a good way. Okay, so let me go to the Android application, and I will show. Okay, it's already open. So I will open the Android app build.gradle file. So if you look at this section, I think these things are like probably something that we are familiar with. But remember, when we are creating KMM based application, this application is by default gonna use Jetpack Compose. Okay, so you don't need to have Jetpack Compose configuration, everything in here. By default, we are using Jetpack Compose. So how do you know that? You can see the implementation side. We have Compose related dependencies installed within our application. So by looking at these things, we know, okay, right now we are using Compose related, Jetpack Compose related stuff. Okay, we are not going to be using XML based UI stuff. We are not going to take anything from there. What we'll be using is Jetpack Compose based things. And one other thing that is stand out is this implementation. It is not something like a normal definition that we have in here. It's something called project. Okay, so this is a dependency of this dependency. We add the dependency of the project shared into our application. So this is how the shared code in here, the shared code will be incorporated into the Android application. Okay, that's obvious because the code that we're going to be writing is going to be in Kotlin. Okay, and whatever the logics, the VM or the model, whatever the things that we need to share will be imported or add as a dependency to our application. So what will happen is when we are building the application, this shared code will be accessible from Android application at least. So that's how we can utilize the shared code or shared things in Android. But for iOS, we can't implement such a thing because first of all, Kotlin is not supported in Swift or Objective-C or any application development as of now. So we need to convert these things into something that Swift can understand. Okay, we will see when we are building the application, when we are running it in a native application, we will see how these things are converted, how these things are actually happening under the hood, what is the mechanism behind it. Right now, we just stick to the code sharing part for Android. This is how we gonna share it. Okay, so if you look at this, that is the file setting gradle. You can define the things in here, the shared libraries and the Android one as a shared project. This is what we call a Gradle project definition. Okay, you can see those things in here as well. That's one way of doing that. SDK directory, I don't think that is something we really need to worry about. So this is where we define multi-platform related build files. Okay, and we are using the extension KTS for Gradle. So Gradle can be defined in two languages. You can the most common way that we use for Android application is using the Gradle file using Groovy files, but also you can use Kotlin as such as this to define the builder Gradle. But that is not something drastically to worry about, but you can use the same things in two different language. Okay, what else? Yeah, let's go with the shared application because a lot of things going to be happening in here. Source code. Yeah. So one thing that we need to be really really think about when you are developing an Kotlin multi-platform application is that other libraries, the libraries that we are going to be using can be shared among. For example, let's say for instance, we need our MVVM pattern to be happening. We use the retrofit in order to make the call to get the information from internet. Okay, so retrofit as of now, we guys can see the Android ecosystem knows we can call these things and work. But what happens with the cross-compiled or Swift code? Can can the retrofit related task, all those things, whatever the logic is written in there, can be converted into Objective-C and still assume to work? We can't ask the developers who develop retrofits to say, hey, we need this application to be converted into Objective-C, and we want to work it like as it is. So it is a simple downfall at this point. Not all the libraries which is available for Kotlin and Android are 100% compatible with KMM. Okay, KMM needs special libraries which are KMM compatible. Okay, if the library is KMM compatible, then you can use that for both iOS and Android. But if it is not, it's up to you to come to a solution or use two different way of communicating these things. Okay, by far right now, the most of the common things that has happening within an application can be done or can be achieved using a KML supported library. For example, we can show you a list of applications. There is finding Chrome is also a problem. Let me get KMM supported. So it is not if you go to the Kotlin multi-platform, you can create your own libraries which will support KMM, but you need to make sure those things are done in a way that all those things are acceptable. Okay. JVM to have the it's not showing all these things. So you might find some alternatives use cases of what we are using right now. For example, retrofit is one of the libraries that we use to get the information from internet. And in terms of working with KMM, retrofit, I think as of last time I read, it was not supported. Okay, so what we need to do is we need to find alternative libraries. Okay, this is something some people consider a pain point in KMM, which support both Android and iOS. So, for example, in this demo this repository, you will find a few of alternative libraries that can be achieve the same functionality for networking. Rather than using retrofit, you can use Kato to do the network calls. So Kato understand the conversation between Objective-C or Swift and Kotlin itself. So if you are writing your logic using Kato, you don't need to convert these or you don't need to do any modification from the Swift side. It will be automatically done for you. Okay, so if you're using a compatible library, okay, remember the name compatible library with KMM, you are in the safe side. You can use the Kato and you don't need to do any much of the dependencies or whatever the conversation that should happen. So the same goes to other one things as well. There are a lot of libraries out there. You can use the serialization, Kotlin Next serialization. This is like the official one supported by, but there are other serialization platforms like if you guys can remember in retrofit we use something like a JSON converter. In Kato we might use something like this. There is a lot of alternatives. The same thing that we can be done there are libraries already out there, so you guys can use this. Okay, so for dependent injection, we use Dagger or Hilt, but in here we have Kadin, DI, or Kotlin. So I think most of the time these things will work without an error, but I'm not saying it is like 100% is going to work. So there is other implementations for reactiveness. You guys can see that there is multi-platform live data. Coroutines are supported. If you are writing anything in coroutine, that will be automatically converted to Objective-C stuff. So you don't have to worry about that. Datetime, versioning, event bus. So I would say most of the applications to be developed by us is having these libraries that we can use out of the box. For example, if we do not have, for some reason, we have a requirement which involves really something native that the community is at least not supporting at this moment, or the community is not gonna do a library release uh, in a scenario like something that we need to really need to work with the native stuff. Okay, the library is not there, but it is something really native to iOS or Android. We can also achieve that. Okay, so using this shared library, we have something called iOS main, and we will look into this section. Okay, so let me explain the counterpart of this, the Android main. Okay, let me open the same thing. So we have this two classes. I think there is one for common as well. Okay, take a closer look at this structure. So it's gonna be something that we will be using. So we have something called the platform class, and one for iOS, one for Android. Let's see how we can achieve real native codes using Kotlin. So we have this platform class. Okay, it's a simple interface or a function, you can say. So the interface is called platform, and it will contain a name. That's it. Okay, and it will have a function. Okay, a function that is not defined. That's why the call expect is there. It's like function definition, like the interface without the body. So the function definition is the get platform. Whenever we call this get platform method, a platform instance will be returned. Okay, the platform instance in this scenario is this interface. Okay, so really simple. We have an interface called platform, and we can call the get platform method uh, as you guys can see in here, and it will return a platform instance. Now let's go something similar, that is something that we are familiar with. Okay, the implementation of this platform method in Android. Okay, so we will be uh, extending the platform or implementing the platform class, which is the general one that we can see in here. And there's the function where if we are implementing the platform, we need to have variable called name in here. So we have to provide something there. So the name is what we called Android, and we have something like this Android OS build version and SDK. So if somebody is creating an instance of the platform, which is called is in Android, which we will call Android platform. So implementation of platform within the Android system. So we will have a platform, and the Android implementation of platform will give us a name with the Android string and the Android SDK build number. So this is something that that you guys will see. It is not something important. Android OS build version SDK. It is not something that is important in the package itself. But it's a definition or it's something that we can call within the Android application and get the value. So if I do a Google search on Android get build version, okay, how can get the build version number of Android? Think this Stack Overflow. This is the not the operating. So the value should be not the build version, SDK version. SDK version. What is the current SDK version that we are having? Android get current SDK version. How can I check the system version of Android? So the current running version of the Android. So if you guys can see that, okay. So we have a bunch of places where we can access Android OS build version SDK. This is a place where if we use this section, we can get the Android SDK version into our application. So it's going to be really simple. If we just need to call this Android OS build version SDK int, and it will return the current SDK number. Okay, so this is how we can access native Android code using the Kotlin code. So this is not even related to Kotlin, or sorry, not related to even Android. This is like plainly calling this build number, and whatever the value that you will find in this variable will be concatenated with Android, and it will store as a name. Okay, so for some reason we are implementing the platform interface. Okay, we are implementing this platform interface. If we call this function, the get platform function, within Android application, okay, within an Android application, we will get an instance of platform, but in this scenario, we will get this Android platform instance. Okay, so for some reason, we call the get package get platform function. We will get a platform, but it's gonna be this Android platform. Okay, so this we can something we can get from the get platform method. Let's go to the counterpart of this. Let's go to the iOS one. Okay, so same thing, we will be implementing the platform interface, but in this scenario, what will happen is the platform that we are interested in is gonna be iOS platform, not the Android one. If you look the counterpart, it is going to be an Android platform, but in here we are calling it iOS platform. Okay, if you close a look at the iOS platform in here, the same thing goes with iOS. We will be providing the name, and it's going to be a string, but the UI device, current device system name, okay, this will give us the iOS version. If we look at the documentation on it, current version, how we get the system version. So we, like in Android, we call Android OS and something similar for OS X. So for For iOS, we have something similar from Apple. If you look at it, this by calling this static method, you will get the iOS the version system name, because the reason behind the system name is if you run this application in a different platform other than the iOS, you will get a different name. Okay, so Mac OS, iOS, you will get different definition for the system name when you are running your application. But in here, we are interested in UI device with the current device and the system name, and concatenated by UI devices current device system version. So when we are calling get platform, it will return a platform. But if you are in iOS context, it will return an iOS platform. If you are in that means this instance. If you are in Android and you are calling the get platform, you will get this instance. But if you are in iOS, you will get the platform instance of this. Okay, so we can incorporate the same functionality, or something should happen throughout the application like this: a common interface and Android implementation, also a iOS implementation. Okay, so this is the common place. This is how it should look like, and this is how it is in Android, and this is how it is in iOS. Okay, so the common interface you can work with in two different platforms. Okay, the next thing that we will be interested in to look at is the greeting class. Okay, we have created something called a class called greeting. Okay, we have this greeting class, and it is containing the instance of the platform. Okay, so we will be using this greeting class, and this greeting class will have an object called platform, and it's going to be a type of platform. And to get the current platform, we will just call the get platform. So when we are using the greeting class within iOS, okay, when we are using this greeting class within iOS or Swift, you will get the instance of this iOS platform interface. Okay, but if you are calling this get platform method from Android device, now what will happen is they will provide you this get Android platform method. Okay, they will call and they will store it in here. So if you call this function, read whatever the string and whatever the return is, they gonna say hello, whatever the platform name, and you will get the result as a string. So this greeting class is something like a shared code. Of course, this platform is also something that is shared, but this is an implementation. Okay, you can create the common behaviors on this application in different places. So the platform is like the common blueprint of our application. The greeting is one of the implementations by using this platform and greeting stuff. But Android is the implementation. What if we do it in Android, and the platform implementation in iOS? This is the one. So we have these definitions. We have these definition shared among these two platforms. Okay, so this is a way of sharing code. But if you find this thing is okay, this is overrated, or this is too much that we need to do, of course, completely fine. You can use the native ways as well. So you don't need to create something like greeting or whatever. You can you can create all these codes in native. So if you are using Swift, you can you have the same thing in Swift. If you are using Kotlin, you can obviously use this code, or you can have it in there. But for some reason, if you want to contain the uniformity of the application, okay, if you want all the application to have this uniform method or uniform implementation, probably you will need uh, this uh, this kind of implementation in our application, okay, to sharing and uniformal. Okay, so the greeting class that we see in here, available in iOS, available in Kotlin as well. Okay, all right. Yeah, so we talked about the shared section, how we can share these things, how these sections are going to be reacting on different devices. If you need different testing on these things, you can have these test cases lined out for you, common tests that you can also use. We'll check upon these things later on. For now, we will not focus on that. We just want to share you guys how code sharing works, and we will see how we can use this shared code in a little bit. Okay, and one other important important thing that you will be working with. Yes, say for example, the dependencies that we talked about. Okay, we talked about we talked about things like Cater, which is both compatible for iOS and Android. Those kind of deployments. Yes, if you put it in Android build Gradle, that would make no sense, right? Because we are talking about libraries that is shareable. But if we have such a library that is not shareable and which is not supported by KMM or some sort of reason, of course we can go ahead and put it in the build Gradle in here. So it will work for Android only. Okay, for Android only. For some reason we have a library that is not shareable or not available as a KMM module. You can put it in here, work as a normal way. For example, Android Android X Compose. Okay, definitely for a near future we won't have this Jetpack Compose kind of things in iOS. So we can assume that Android X Compose is going to be something really native to iOS, really native to Android. You won't find this in other platforms or anywhere else. In a case like that, definitely we will put those dependencies in here. But a library that can be shared, you have to put this is in common main dependency section. It's dependency section. In here, you have to mention like something like Cater or anything that we will be using. You have to put it in here because it makes sense to have the shared libraries in a shared place rather than to its original form. This is only going to happen for Kotlin and Android projects because obviously in iOS application you don't have any space to define Gradle dependencies. Okay, so it's a matter of a place within Android and shared. Right now, you do not need to worry about uh, um, the definitions. If it is shared, make sure it is KMM compatible. Okay, that is the first thing. If it is KMM compatible, put it in here and you can get things done. If it is not, you have to go to Android and during in here, you have to implement that your own. Okay. Uh, but as long as you have the common main, okay, even though let's say even though that two dependencies are there, for Android main, you can you can use those libraries in two different platforms. Just have a simple simple common interface or common section like this, and implement implement its own way of doing that in the Kotlin class that you can see in here. Okay, so iOS platform is implement for iOS like this. Android platform is implement like this. If you have something that is not shareable, of course, you can have the dependencies for each and every platform and call these variables or call these things like what we have done in here. So this is a special binding way of doing things in Kotlin multi-platform. You can call library methods or you can call system methods like this. We will have a look around these kind of interpretation within our application. Right now, just remember we can call native iOS or like something that we have defined in the code section like this. This binding is very powerful, and we can use this binding to implement the system as we can work with. Okay, we talked about shared, we talked about the dependencies where we need to put those things, and what if what is the use case we should follow if the library is not supported by KMM. Okay, so we'll have a quick look. Still, I think I have some macOS related stuff to be downloaded, and it's gonna take a little bit while. Yeah. Okay. No mind. We can go ahead and see few of the um, important files. So these are like really important when we are developing. Where was that? It was in the build executor, right? Now I need to have the application ready. So right now, let's see whether the SRC application is ready. So at a glance, you can see the Android manifest is there. Yeah, it's be the same old application that we'll see, and resources. It's gonna be a little bit different because we are using Jetpack Compose to power these things up. So it will be a little bit different. The resources, it does not have layouts in XML. Those kind of things are omitted at the moment. Okay, by the way, do you guys need any other information with the KMM and its approach? Do you guys have any questions before we move on for the further exploration? Anything you guys need to know? Yes, it's a good time to ask questions. Okay, so far so good then. So we have the main activity KT. Okay, as I mentioned earlier, any one of you have tried out Jetpack Compose? Anyone raise your hand, please, if you have tried out Jetpack Compose. I have used Jetpack Compose. Nobody. Okay. Anyone have used Flutter or Swift UI kind of things? Flutter? Yeah. Please raise your hand. Okay. Did we do a lecture on Flutter last time or not? I can't remember exactly this course content. Did we touch upon Flutter? No, can't remember. Did we touch Flutter? Anyone can say yes or no? Hmm. Everybody's alive, right? Hello? Okay. We did work with Flutter. So the concepts with Flutter and these things is gonna look familiar for you guys. Okay. And when we go into Swift UI and Jetpack Compose, you will be even more surprised because from my perspective, it's kind of like always the same. Okay, almost everything is pretty much same when you look at Jetpack Compose and Swift UI. Right now, the starting point for our application is called main activity.kt. Okay, this KT file, and you can see it is super simple compared to the XML application. We have an activity. We have the same life cycle, activity management, all those things within a Compose application. Those fundamentals for activity is not uh, changed at all. There can be certain parts where will be changed, but most of the time it's really intact with the existing system. So we have this method called set content, and um, it's basically going to set the activity itself. Okay, the set content will have something called my application theme. Okay, and within the application theme, we will have a composable called surface, and surface have the modifiers. We call these modifiers, and the modifier for this one is the surface will take the fill max size, and the color of the surface will be the material theme, material colors background. So we have introduced material theme. We will show you, I will show that in my application theme. And in here, we just show the color as material themes background color. That is, it's going to show. So in here, in this within this surface, okay, we will have another composable called greeting view. Okay, if you guys go down into the composable, it's called composable. It indicates it is a small view sort of things in in Jetpack Compose, and simply if it will be provided with the text, and the text will be shown by this text view. We call this views, and whatever the text we have followed, the modifier will have also something called text. The text will be assigned to that, and it will return that. So this is a really simple Jetpack composable view, but in here you can see that greeting settings is calling a class called greeting and greet. Okay, so this will return a string. That string is passed to this greeting view, this view right there, and it will just show that view. That's the simplest form of application that you can see. But if I quickly go with the my application theme, it is really simple thing where the theme is having few modifiers, whether we are using the dark theme, what is the content, and what are the colors that we're going to be using within the theme. And these themes will return a material theme. Okay, so within the material theme, our application is nested. Okay, within the application theme, our application is nested. So whatever we have defined in here, the theming of our application will follow these changes that we have done, especially with the typography, with the dark colors, light colors, and the shape. This is something I have defined in here, and we will return the material theme, and based on that material theme, we will be showing the surface, and the surface have a small composable view which we can see it in here. So pretty simple compose application. If you are working with something like what do you call XML based application, quite contrast to the definition what we have done, but it's easy compared to we don't have any XMLs. Right now, we haven't introduced any VMs or anything like that, view models or something like that. But it would make a lot of things easier when we implement the same thing with the APIs and MVVM model. So you'll guys see the interface that we're going to be building is totally going to be based on these codes. Okay, so like Flutter, what we have seen in Flutter, we do the UI coding in we do the UI design in code. Same goes in here. Okay, so it's going to be pretty easy to implement UIs as a developer. So yeah, one thing that we are going to be curious on this greeting class. Let's have a look around where this greeting is coming from. So you guys can probably see my theme, the surface, all those classes are coming from material or something like that. But this greeting class, you can see it is coming in the same package that we are having our application. Okay, so if I click on this greeting class, oh sorry, I can't create, I can refer this. But if I click on the reference to this greeting class, it will directly go to the shared common main and this greeting class. And this greeting class has a function called greet, and it will return hello world from there. So what I'm doing is I am calling this greeting function within Android context. Okay, I am calling this greeting function within Android context. So when I call this, okay, KMM automatically know we are in Android context. The platform, the get platform method, since we are in Android, it will get the Android platform related detail and the hello and whatever the platform name that we have defined in the Android main. This greeting message will return that. Okay, we are calling this greeting method from Android context. So it knows, okay, now I have to get the greeting class from Android implementation. Okay, this is the common place. But when you are compiling it down, it is known for getting the correct implementation of that platform. So we when we call this main activity in Android, this platform and this greeting methods and this platform is used to create the UI, used to create the data. And when you are calling the same thing, if you call this greet from iOS, it will know where it is going to be coming from this platform implementation. So I will go to the iOS app, and you will find that it's not ideal to open what do you call iOS app in what do you call this Android Studio. But for reference, or for just to have a quick peek, this is something similar to the Jetpack Compose application that we have seen. This is, by the way, not Kotlin. This is Swift. Okay, you might find that the Kotlin and the Swift is somewhat similar. I find confusing for me all the time as well. So no worries there. So this is like a Swift UI application instantiation. Okay, we have a body, we have a window group, and we will show the content view. It's, if you look at the main activity, it is same up until this. Okay, the content view in this scenario is in a different structure. We do not have things like we have classes. Actually, we have separate things like structures. We will discuss on that while we are gonna working with Swift UI. But for now, think this is the view. This is the view that we're going to be returning, and it's going to have a body, and it's going to show a text, and text will be greeting. Okay, how do we get the greeting? You can see that greetings is called around here as well. So since it is iOS and Swift, obviously this is not gonna be referring to the shared common main greeting class that we see it in here. So because this is in Kotlin, this is in Swift, you can't call something in Kotlin using Swift. That is not, we are not there yet. But we have the next great thing. When we compile this class, it automatically convert this greeting class, this Kotlin source code, into Objective-C class. We will see that in a little bit later after the application compiles itself, which is taking like a long time now. And the same thing goes here. The greeting will call the greet method. But in this scenario, now Kotlin multi-platform is not going to look into the implementation of that same application, but not in Android, but in iOS. Okay, the platform implementation will be based on this iOS related things that we have done so far. Okay, so really easy. If you consider I have to close all these things because it's hard to find. Yeah, so the content view, we are calling the greeting view, which is cross-compiled into Objective-C, not even Swift, because ultimately Swift, as I mentioned earlier, Swift things will be compiled into Objective-C as well. So right now, the greeting class will be compiled or used, whatever the definition we had in common will be changed into Swift code, and it will be working. Okay, so we have these things like the structs and all those things in what do you call the in Swift UI. We will have a look at it on a separate note. Right now, we'll stick with these things. Unfortunately, I think given the internet connection that I'm having, I'm not able to show the running of this application. But you guys see that I did not touch any code at this point. I basically explain the structure and how it works. So if you guys are curious enough, go ahead and create a KMM project and give it a little bit time to download everything, and we just hit the play button. If you are in Android, probably you will be able to run it in simulator and get the preview of it. If you are having a Mac, just open this iOS application um, in Xcode. You will have the same similar looking application. It's not going to be like a one user interface like we do in Flutter. Okay, so in Flutter, what we have to what we can expect, Flutter or React into some sort of hybrid frameworks. Even the UI that we are running, we are writing is going to be one singular thing. It's going to be a widget. It's going to be a widget like what we have seen in Flutter, or stateful widget or stateless widget, and that would be rendering in both iOS and Android. But in here, that is not the case. The view, you have to define it in the native form. Okay, this is SwiftUI code, which will be represented in the greeting message, and this is gonna be Jetpack Compose code, which will do the same thing. It will show the application name. Okay, that's simple. So two application achieving the same thing, but the thing is the logic. You guys can see the logic in here. Greeting and greet section. This one, it is common for both platforms, but not the view. View is not common. So the view model and the model itself is in a different component, and it works. It works from there. Okay, no need to have it in even the same language or in the same project. Okay, so you guys can see the clearly how powerful MVVM is in a scenario like that. We have a view in native, view model in another language, model in another language. So as long as you follow the MVVM structures correctly, you can separate these concerns and have a nice looking application. Okay, so with the next lecture, we will continue on these things, and we will see how we can define these MVVM structures and share the codes, share the values, and how it really works. Then we will utilize the MVVM, we will utilize the same application to go further down in Swift UI as well as Jetpack Compose. Okay, so we will be following MVVM pattern, but in a KMM model, either we can share it or we can have local. We will explore all the solutions. We will see the pros and cons of each and every solution that we can be using, and let's see what sort of other things that we can introduce. Okay. Any questions up until this? Anything related to KMM, how it is structured? Obviously, if you are really keenly interested in, you can have more into Jetpack Compose, but we will be definitely talking about having these things in upcoming lectures. But Jetpack Compose is as much as fun as Flutter itself. You can really easily learn. Same goes to Swift UI. You will see how much similarity these frameworks and platforms have in common. Okay, any questions up until this, guys? Okay, if you have anything, just let us know in the section. Make sure you guys follow with the assignment that I have given. And that's pretty much it for today. I'll stop recording.